Hey guys, welcome to part 2 of this Exploding Kaleidoscope series. In this section we'll be looking at how to do this glass shatter simulation, and then later we'll be looking at how to apply a post effect to create this kind of time warp effect that you can see here if I press play. Alright, let's jump into it. Got my empty scene. First thing we're going to do is drop down a geo container, same as before, and drop down a circle again. Switch it to polygon and division size to 80. This time we're not going to mess with the arc angle, and instead we're going to increase the uniform scale by 2 to make it a bit bigger. And then we are going to use an extrude to kind of give this disc some thickness. Doesn't need to be much, something like 0.1 is probably enough. Nice and thin pane of glass. And then we're going to enable output back, just to complete this geometry. Next, we are going to shatter this into glass shards. Luckily for us, there is the material fraction node. Drop that down. It's an amazing node. I highly recommend you play around with it. We're not going to use the default material type of concrete. We're going to use glass. You can see there's also wood. So switch on glass, and then we're going to hook it up. Visualize the node. And you can see by default, it's using this scattered points random seed to place the origin of the cracks randomly. We don't want this to be random, however. We want to put it right in the middle. So to do that, we are going to drop down and add and pick the default point, which is at 0, 0, 0, the origin. And then we're going to plug that into the last input, the material fracture. So now we can disable this random scatter and then enable input points. And you can see it puts it right in the middle. At the moment I have wireframe on. So if yours looks like this, then all you have to do is do Shift W to enable wireframe. Equally, another useful node is RBD exploded view, which might help you debug your shattered material. I'm going to delete that. All right, this is the default. We can definitely improve this. So we're just going to change a few settings. We go over to cracks. We can decrease the minimum width and maybe decrease the discontinuity size, something like 10. We're getting way more cracks now. Then we are going to enable fracture per piece. And now we have this slider of randomness. We can then crank that up to get a bit more randomness in there. Then a really useful tab is the chipping tab, which we're going to enable. It's going to give us these little smaller pieces, which really help increase the detail in the sim at the end. Chipping ratio, we'll crank up. Also randomness, maybe a bit more directional noise. And then we're going to increase the corner depth as well, just so it eats more into these glass shards, as you can see here. Now, there's nothing magical about these settings. You can definitely play around with these yourself. This is what I used in the end because it gave me lots of pieces to work with. But like I said, you could probably play around with this and improve it a lot more. And I encourage you to do that. Next, we're going to go to the constraints tab. And by default, the strengths are really high. We're going to not need such high strengths for the constraints because we want this disc to shatter easily. So we're going to turn these way down, something like that for now. All right, the next node we're going to use is the RBD configure. Just going to prepare our geometry for the simulation. The only thing we're going to change for now is the type, which is glass. And then finally, we can drop down our RBD solver. You can see I'm automatically connecting it by right-clicking on the output, and then that brings up the tab menu, which I can then search for RBD bullet solver, like so. Okay, the defaults are pretty good. We're not going to play around with them too much. The only thing I'm going to decrease is the sub-steps, just because this will be quicker for us to get some iterations out before we can crank it up right at the end, just before we cache it out. The next thing we're going to do is turn off gravity because we don't want the disc to fall. We want it to just hang in the air. So in the forces tab, you can see the default is minus 9.8 in the Y. We're just going to set that to 0. All right, if you press play, nothing is going to happen because we haven't got anything interacting with our disk yet. So if we go back to the beginning, we can then create some geometry to smash through this disk. So to do that, we are going to drop down the tube. I'm going to switch it to polygon, enable end caps. And then we're going to set the second radius value to 0, and then decrease the radius scale as well to create this kind of spike. Then we're going to increase the amount of rows, increase the amount of columns, and finally set the orientation to Z. So that's lined up, ready to smash our disk. All right, the next thing we're going to do is drop down a mountain. This is to kind of create some more interesting shapes, which is always a good thing when you are messing around with simulations in Houdini. Mountain is almost always the go-to for quick variations. Defaults are too high, so we're going to turn down the element size, turn on the height as well. And then maybe play with the offset until we get a noise that we're happy with. Something like that. All right, next thing we're going to do is animate this spike, this wobbly spike, to crash through our disk. So to do that, we're going to turn on the template flag for our poly extrude, just so we can see where our disk is. See, our spike is way too small at the moment. So we're going to drop down a transform just below our mountain. Then making sure we're at the beginning of our timeline, we're going to slide it back. Just increase the uniform scale as well. Something like that will do. And slide it back some more. Value of 2.7 is probably enough. So we can use Alt and left click to set a keyframe. Equally, you can right click and go to the keyframes section and set keyframe, or you can just tick the keyframe button just next to your timeline. I like to use a shortcut there, it's a bit faster. Then we're going to jump to frame 120, and we are going to change the value to be on the other side of the disk. Something like minus 4.4 is probably enough. And again, use Alt and left click to set that keyframe. You can see the two keyframes are visualized in the timeline. It's a very simple animation here. And that is our collision geometry. So you can see if you hover your mouse in this fourth input of the RBD bullet solver, it's collision geometry. So we're going to hook that up. And we are almost ready to go. So you can see if we visualize the bullet solver, it is displaying our collision geometry in blue, which is helpful. We can turn that off if we just want to see the disk though in the Visualize tab. Show collision geometry. Leave it on for now. We're just going to hit play and see what we get. Nothing is moving, and that is because the default of the collision object in the collisions tab. So we're just going to enable deforming static object instead. And if we go back and hit play, we can see it's now moving. All right, I've let that cook. You can see that our simulation looks like this currently, and we can leave that cooking. Like I said, you can go back and play with a few of these settings until you get a simulation that you're happy with. I'm going to call that a day for now, and I'm going to cache this to disk. All right, our simulation has finished caching. Let's make sure that load from disk is enabled, and then we can play that back. You can see that explodes out. Nice. Let's assume that we're happy with that. The final thing we're going to do is, just to make this whole thing more interesting, is mess around with the playback of the simulation, so that instead of just playing linearly, it's going to play with a bit of interesting variation, a bit of reverse effects thrown in. So to do that, it's really simple. First node we're going to drop down is a time shift, and that is so that we can clamp it, so it's not going to try and read a file that doesn't exist. And then we can use a time blend to interpolate between our frames, so we have some subframes to play with. And then we are going to drop down a wrangle. We're going to use some vex, very small amount of vex, to set an attribute that's going to control our time flow. So we want to run it over the detail because we only want to do this once. And we are going to initialize an attribute called set time. And we are going to use the fit01 function. And that's going to fit our attribute, custom attribute called time control. And that is going to be our first frame to our last, 240. Semicolon, and tick that. So essentially what we're doing here is we're remapping to set time, which is our custom attribute, which we are going to use with another time shift to control which frame we're looking at. So at the moment the default is $F, which is obviously the current frame. We are going to set this to our set time attribute. So if we replace $F with a function called detail, and we are going to look at the first input, which is 0, and then use a quotation mark to look for the attribute set time, and finish off with another 0. So if you visualize this time shift and look at our attrib wrangle, you can see that if we move this time control, we are messing around with the playback of our simulation. So the final thing to do is to keyframe this time control. So you can mess around with this as much as you like. I'm just going to play this back just to show you what it looks like. Explodes out, and it goes back in. So the last thing is that you'll notice this is playing back with a bit of a stepping effect, and that is because integer frames is ticked by default. So if we untick that, you'll see we are then allowed to read in subframes, which we have created with this time blend. So that should play back a lot smoother now. All right, that is the end of part 2. In part 3, we'll be looking at how to combine our kaleidoscope effect with this simulation. Thanks for watching.